Okay, as a review, we're going to go back to several of the problems that we did on your packet, page 3. Mary, yours should be numbered. Okay, your page numbers. It's this page. And we decided about solving quadratics. This is a review from Tuesday. Now, in order to solve a quadratic, it must to 0. If it's not, everything is going to be wrong. And then the next step is to factor the quadratic and then set your factors equal to 0 and solve. Okay, here are the down. Also, I gave you a handout when we started the quadratic section, and it was the steps in factoring, and then kind of in the middle it says how to solve quadratic. Go ahead and get these down quickly, and we're going to, on page 3, they've done this stuff for you. They've done the top 2 steps. Looks like after it's been factored, okay, on page 3. So I'm going to go ahead and erase this. Anybody need it longer? So let's worksheet page 3 of the packet 3. They have already done the factoring for you. Before they factored, it had to be equal to 0. So that's a given there. Now, I will remind you of the little story that I usually tell people when they're solving quadratics. Okay, and the teacher comes in with a big smile and says, I have a riddle for you. And she said, I have a mystery number in this hand and a mystery number in this hand. The numbers is when I multiply these 2 numbers together, I will get 0. Okay, and so I let you think for a little while, and then I say, so tell me about these numbers. What will multiply to give 0?
0.
Okay, one of them has to be 0, right? Because 0 times 2 to be 0 in order to get an answer of 0, right? So either this one could be 0 or this one could be 0. Could both of them be 0? Yes, they could, because 0 times 0. Thank you, Josh. 0. Keep that in mind. Hang on to this story. And now let's look at our problem. Here are my mystery numbers. Here's one mystery number here times another mystery number. If I have a mystery number times a mystery number and I get 0, then either this has to be 0 or this has to be 0, but they can both be 0. And so that's what we're going to do. We're going to say this one could, or this one could be 0. And all you have to do from this point is the very beginning of how we used to solve equations. I want to solve. Now I have 2x equals 1. And in order to get rid of the 2, I need to divide by 2 and divide by 2, do 1/2. Now quadratics, the majority of the time, they're going to have 2 answers. Sometimes 1, sometimes no answers, but the majority of the time you're going to get 2. Then we solve this other one with the very simple steps that we learned a long time ago. So what they're saying is that I can take this 1/2, put it where x is in this, okay, it whatever will equal 0. And then I can take this -4/3 and also put it here, and it would make a true statement, okay? That's what this is saying. Now, as here at the end of this packet, we're going to have to use this. I want you, Tuesday I explained this, but I want you to know exactly what you're finding. You're finding the x's, or you're working a quadratic, which is what we've been working with for a couple of weeks. if it's a quadratic and we graph it, it is going to make what we call a parabola. It's either this way or an upside down. What we have found here is where our parabola crosses the x-axis. So let's say positive 1/2 is about right here, and negative. So your parabola is going to come through those places. That's where it crosses the x-axis. That's what you're finding when we're solving answers are where it crosses the x-axis. Okay? Sometimes it kind of helps to know what you're doing. Okay? Any questions, you guys online?
I kind of don't get it.
Trying to keep track. How did I know?
Yeah.
Oh, I'm just saying it's approximately there. Yes.
Yeah, but I don't know where that goes.
Oh, usually,
What number?
yeah, I'll make it, well, let's do this,
Yeah.
right here. Row, here's 1, so 1/2 is right here.
Oh, between one.
Yes, between 0 and 1. Okay, and then 1 and 1/3, so it's a little bit over 1, and it's in a negative direction. There's 1, and about 1/3 would be there. Okay, okay, and so we'll do that a lot more. Okay, all right. So any questions on this one? I heard somebody talking to me just a minute ago. Oh, I see. You're good. Chatting is helping today because of my speaker. I think I'll talk to the IT guys. There's no sense in it. I haven't changed anything. Well, I don't know that we need to. Let's go to page 3, packet 3, page 4. And let me move the chat out of the way here. So again, it says we're going to solve these quadratic equations using factoring. Okay, there's actually another way to solve quadratic equations. So they said do it by factoring, which is this, that they haven't even factored it for you. And as you go through here and look at number 2, that isn't even equal to 0 yet. So they're on page 4 of this packet. They're making us do everything. Find out. Our key word here is solve. So that means we're not only going to factor, but from the factoring, we're going to actually solve this. So let's do number 1, and then we're going to hit number 2 also. Number 1, plus 6 equals 0. Now we said before we can do anything, before we can factor, before we can do anything, we equal to 0. Now I keep talking about a quadratic. A quadratic means that the largest exponent is a 2. Then our equation is a quadratic, okay? As long as the biggest exponent is 2. The thing I need to do after I figure out that it's a quadratic is to make sure that it's equal to 0, and it is in this case. Then I'm going to take this side, and I'm going to begin my factoring process. The first, and we found out a shortcut is if this is an invisible 1, and this doesn't have a variable in it, probably no greatest common factor. Our second step is to look for special. Specials only have 2 terms. This has 3, so no specials. The third step that we listed here several times, we're going to look for groupings. Groupings have 4, 2, 3 terms. So our fourth step was to go to the 2 parentheses, and we're going to factor here. Now I'm going to go a little faster on the factoring, but look at those. If you're still having trouble factoring, the front times the front has to give you the front term. So we know it's V times V. V times V gives you V squared. We've learned to isolate the middle in it. Now we have a choice of the factors of 6. It can be 1 times 6 or 2 times 3. Now the 5 and the 6, because if I subtract this, I'll get 5. But if I add this, I'll get 5. So which one I want to get 5? So the way that you can tell is to use the 2 and 3. If it's a minus, you're going to use the 1 and the 6. So I have 2 and 3. Whenever I check this, I have 3 V's, and I need to add or subtract these to make a positive 5V. I got that from here. For this to happen is if both of the signs are plus. I'm going to have a positive 2 plus 3 And this is my factor. You have to have the quadratic equal to 0, factor it, then we're ready to solve. This mystery number times this mystery number will give me 0. So that means 0 or this is equal to 0. When you solve for v, you're going to have v equals a -2. These are the answers to solving this quadratic. The first step, make sure it's equal to 0. Second step, and then if they want you to go from factoring to solving, you set this one equal to 0 and this one equal to 0. And here are your answers. And again, later on when we're graphing, we will have a point on -2, and we will have a point on -3. So this is going to be, because this parabola has to pass through both of my answers. These are called the answers. They're called roots. They're called zeros. They're also called roots, and they're called x-intercepts. Any questions on how to take care of from the quadratic all the way down to the answers? Any questions?
Well, in order to do last year.
Thank you. Thank you.
Hopefully it'll be in a couple of weeks.
Okay, I'm going to need a big O instruction. Thank you. Now let's do one of these problems where it's not equal to 0 and find out what we have to do there. Let's look at number 2. Number 2 says g squared minus 3g equals 4. So when we look at this, don't be frightened. The quadratic, because the biggest exponent is 2. And then I know if I'm dealing with a quadratic that it has to be equal to 0. Right now it's equal to 4. And so I can't do a thing with it. What I have to do is get rid of that, and then it'll equal 0. So I'm going to subtract 4. But we found out whatever you do to one side, you have to do to the other. Now, I'm not going to put the -4 under here because it doesn't have a g4 under this, because these are g squareds, and that doesn't have a g squared. So I'm going to make it its own little place over here so I don't get mixed up. Now, it's out, and that's what I wanted it to do. And so I bring down my g squared, my -3g, and my -4. After that, the only way that I can solve is to factor this. So I have g. I have a choice of either 1 times 4 or 2 times 2. That makes 4. I want one of these that will make the 3 a -3. 1 and 4. So I have 1g, 4 g's. And I need a negative. So I'm going to have to subtract these to get 3. And the largest one is going to have to be negative in order to get a negative. So my 4 is negative. My 1 is positive. Now I factored. And the instructions say solve. So I need the g by itself. So now I'm going to have g plus 1 is 4 can be 0. So g can be a -1. Guys, I want to make sure that I don't miss your.
I'm okay.
I like it. I like it. I'm a little behind on your chats, but you're doing great. Keep it in 1. Or g can be 4. So again, you can see that on your graph, you will have a -1 on the x. We'll go through these points. Even though this says g, they're x-intercepts. Okay, always. Any questions on this one? Are you? You've missed some of the earlier stuff, and that's, I'm here. Okay. Now I noticed one on this page that we probably need to look at. Any questions, Sandra, Josh? Okay. And I think that we probably need to talk about. Yes, this one. Well, 6 or 7. I'll do 7. Same page, number 7. Okay, this doesn't look like a quadratic yet, but in order to look at the, so let's use the distributive property, invisible 1, invisible 1. So 1k times 1k equals 4k equals -3. And now we're back. We can see that it's a quadratic. We can see that it's not equal to 0, so we have to do something about that. So now we have k squared minus 4k 0. And so we're actually at a starting place now. As long as the quadratic's equal to 0, we can factor now. In order to get to be negative, where we add negatives together. And so here's our factored quadratic. And from the fact 0. Are that k is 1, that will work in the quadratic, or 3 will also work to make a true statement in the quadratic. These are the answers. These are also what they're going to call zeros. These are the x-intercepts where the parabola crosses the x-axis. Let me check these. See if there's anything else that might cause you problems. I'm looking on page 5 now. Page 6. These will be, and 7. These will be 9 on Monday, I think. Yeah, Monday. And the quadratic formula on Monday. Notice that it's just Thursday to tomorrow on Friday. I'll be doing my annual doctor stuff. So no class, no Zoom tomorrow. No, just me. I'm hearing, I'm good, okay. So I'm going to stay on the Zoom as long as you guys want to stay on and ask questions. It's a very good chance you may have to just call me if I need to hear your voice. But other than that, okay, and if you're just bored to death, I've decided that we're not going to do packet 2 at all. We're not going to do packet 2 enforcement and practice if you need to practice more on factoring. Okay, so packet 2, we're not going to do that in class. It's just review and practice.
No.
Any questions? I see you, Sandra. Josh, you okay? I'm assuming it's all good. Okay. All right, so I'm through for today. I'll be sending out a Zoom invite, but remember, it's not, you guys have a great weekend. Those of you that want to stay on, feel free to stay on.